Wagwan's my G. I'd like to welcome you to Partially Secure, and after some extensive market research, I'd also like to welcome you to the very first episode of our new series, Super Fun and Cool Web Challenges. In this series, we'll be walking you through various web challenges on the popular CTF-style pen testing website Hack the Box, and the point of these challenges are basically to improve your skills and knowledge of common website and web app vulnerabilities. And this also gives you the opportunity to finally be able to brag to everyone you know about how you're such a cool and romantically available hacker man. So today we're looking at RenderQuest. RenderQuest is a super fun and cool web challenge on the Hackbox platform that centers around using server-side template injection to execute a malicious payload on the site. As you can see, it's a fairly easy rated web challenge, so if you're looking for a good place to start, this is, adequate. So the great thing about web challenges is that they're pretty simple to set up. You're just going to start ahead by clicking to download the files for the challenge, dragging it to your desktop, and right clicking to extract here. It will prompt you for a password, but luckily for you, there is a big fat zip password right there on the Hackbox website. And just pop that in, and you should be able to access all the files that you'll need for the challenge. After this, there's not really too much else to do. You just click to start your instance, and this will give you the IP address for your challenge. So if you just go ahead and copy that and pop that into the search bar at the top of your web browser, hit go and just look through the website to see what you're working with. And you're just kind of looking for anything exploitable. General rule of thumb I like to follow is that if it's an easy boxer challenge, it is going to have an obvious exploit. Now, if we look at this page for any longer than approximately 0.3 seconds, we can see this big fat input box just chilling at the bottom of the page. Now, after our previous discussion of obvious exploits, we're just going to go ahead and classify this as our obvious exploit for obvious reasons. So if we just head back over to the site here and chuck into this input box to see what response we get an internal server error. Since we have access to the files for this web challenge, we're going to start off by looking through these to see if we can find anything interesting. And first page here, we got the flag.txt, which is sadly not the flag we need to input to complete the web challenge. One can dream. Next, we're going to check the challenge folder, and basically in here we see a main.go file. Now sadly this file extension does mean that the file is written in Golang, but it sounds interesting, so we're going to go ahead and look through it. But if we head back up in the file, we can find this other interesting function called fetchServerInfo, which basically takes a command as a string. And if we look even closer at the function, we can see that it contains the section exec.command sh, which is used in Unix to execute shell commands. So basically this means that this is the function that we want to use to execute a command server side. Now there's multiple ways which we could exploit this, but this time I'm going to be using WebHooks. A webhook is really similar to an API, but the difference between them is that an API has to send a request for the data and wait for the server to send a response back to the request, whereas a webhook functions more so an announcement by the server that an event has occurred. And this is a really useful function for a lot of websites because it means the website won't hang whilst waiting for a server response. And these webhooks, they can be triggered in various ways, such as filling out a form on a website, initiating a chat, or in this case, when you click that big fat render now button. So anyways, we're going to go and visit this fun little site called webhook.site. And this fun little tool gives you a unique URL which you can use for various things, but namely you can use it for sending requests or data through the URL. So we're going to go through and edit this request. First we see the status code, and we're just going to go ahead and leave that at 200. That is just the OK code, which means our request was successful basically. And then next we're going to go through and change the content type to plain text so we don't have to input some weird HTTP content. And then onto the actual content part. To start off, we're going to use these double curly brackets, and basically these bad boys right here, they mean that we can just chuck whatever between those and they will be evaluated by the server. So for example, if we threw in 7-7, it would return 0, and yeah, so with this knowledge, we're just going to start off by calling fetch server info, that function that we found previously in the main.go file. And remember to throw this little dot thing in the beginning as well. And for now, we're just going to use the command ls-la to check if we can display the content of the current directory that we're in. So we can just go ahead and save that and copy the URL, and then we head back over to the website and paste the link in the input box and press render now. And as you can see, we can now view the contents of the current directory, meaning our code worked. So usually when we know the directory location of the flag already from the files, we can just navigate from our current position and read it. However, as you can see in this file, there's a function to rename the flag name to include a randomly generated integer at the end of it. So what this means is that we have to go back and navigate to the directory of the location of the flag to view its actual name. This means we can go back and edit our request to navigate through the directory. So this time we're going to use cd ... to go up a level in the directory, and once again use ls-la to view the contents. Since we want to execute two separate commands here, we need to chuck a semicolon at the end of the first command just to let the server know that it's two separate commands that we want to execute rather than just one whole long command. Then, once again, we're going to go ahead and save our request and head back over to the website to run it again. And as you can see, we're now viewing the next level up in the directory. And our main point of focus here is the flag.txt file, and that's what we really want. So now we know the directory location and the name of the flag text file, so we can go back and edit our request one last time. This time, instead of displaying the content of the full directory, we're going to use cat to read the contents of the flag.txt file. And so for final time, we're going to go send our URL through, and as you can see, we now have the flag for this challenge. And with that submitted, we have now completed our very first web challenge and are one step closer to being a super cool hacker man. Congratulations on getting to the end of the video. If you're even more confused about this web challenge than you were when this video started, click the link in the description and that will bring you to a vaguely adequate write-up for this challenge. And if that also doesn't help, well, that's not very surprising because I also wrote that. But anyways, good luck and farewell, fellow offensive security enthusiasts. Bye bye.